All right, hey there. So, why is the slope of a perpendicular what it is? Why is the slope of a perpendicular the negative reciprocal? Here's one reason, one way to look at it. So, some preliminaries. Um, I'm going to use some geometry for this, like proof. So, first of all, we need to remember that all the way around a point, it's 360 degrees. So half of that is 180. That comes from like ancient Greece and ancient Mesopotamia. Um, all the angles on one side of a line around a point are 180 if they got the same vertex. So it's only like something like that. So, we got a 90-degree angle here, an X and Y. X and 90 and Y are 180. But remember, if that's 90 and that's 180, X plus Y are 90. And all of them, remember, are 180. Okay. So, that's some background we need for this proof. It's requisite knowledge. Number two, if you have a right triangle, the angles add to 180 of a triangle. I just don't use a x plus y plus b. We'll say x plus y plus 90. Again, x plus y plus 90 is 180. Because here I'm using specifically a right triangle. I was going to use A, B, and C, but then some people confuse that with the Pythagorean theorem. So I won't. Those add up to 180. But then take away 90. These two have to be 90. Okay. So that's another thing. Angles of a triangle add to 180. Around a point on one side of a line, it's 180. Number three. Similar triangles have sides that are in proportion. And they're the same if they got two angles. This and this, we can call it A, B, C, D, E, F. I guess G, A, B, C, D, E, F. So we have these triangles, and ABG has this in it, 90-degree angle. So does CDG. So does EFG. But they all have angle G in it. And by geometry, they're all similar by the angle-angle similarity theorem. And when figures are similar, they're in proportion. So we'd have AB over GB equals CD over GD equals EF over GF. So this one over the bottom equals up and down over the bottom equals up and down over the bottom. They're corresponding sides. Okay. So those are some things we're going to be using in this. And of course, you got to know coordinate systems and stuff and lines. But now, if we got a coordinate system and we get two lines, and we want to see about their perpendicularity. We have a line here. Then, of course, for one thing, if something's perpendicular to it, it's got to be going in the opposite direction. So, if this is a positive slope, this has got to have a negative slope. Or since this one's negative, this is positive. It's got to be like that to be perpendicular, as we can see. And if you don't know that, it's something you can look up. Time is limited and finite, and I can only cover so much in this video. But negative slope, positive slope. Now, on their perpendicular, I'm not going to mark it to clutter things up. If we start with this point, and we go, remember slope, m is rise over run, change in y over change in x. So we start here, go up and over. These are perpendicular. We got a right triangle, and we'll say this is like up a over b. So the slope of the red one is a over b. Now this other one, start from the same point. If we go down and over, it's also a right angle. And so there, remember, it's 90 because they're perpendicular. That's like the premise we're working with here. They're perpendicular lines. So notice all these add up to 180. That plus that plus that. But if we say x, put it in black, maybe you can read it better. X, y. So x plus 90 plus y is 180, as we went over before. And then we subtract 90. X plus y is 90. But as we saw, the angles in a triangle are 90. That's 90. These add to 180. This one's y. The other one's got to be x. This is x. The other one's got to be y. So they're similar triangles. We only needed one angle for that, just the x or the y. But by angle-angle similarity theorem, the triangles are similar. So on this one, if we want to figure out the slope, okay, so I was just using x and y for variables to make it up, to show this part. Now, so as not to confuse with slope, I'll erase them. We use x and y all the time in algebra, so people are familiar with that. Now, I'm going back to the y being this and the x being this. That was just for angles. So here, on this one, that's our delta y, our up and down. And this is our delta x. And so they're in proportion. And we can say, we can mark them off as in geometry. They're this and this add to 90. As we said, these are 90. This would be here. So we got to get corresponding sides. So the slope of this one, of our perpendicular, is delta y over delta x. But it's equal to this because they're in proportion. Now, the delta y is opposite the 1 mark, and that's the b. And the delta x is opposite the 2, and that's like the a. They're corresponding. You know, we go from the 1 mark to the right angle. That's our delta x, and that's on bottom. From the 1 to the right angle is our a. Those are corresponding sides. Then from the 2 to the right angle is delta y. From the 2 to the right angle is b. So the perpendicular is that. But remember, it's going down. So it's going to be a negative. And that's why it's the way it is. So for this one, if the slope is a over b, we flip it and take the opposite. And that's, we get negative b over a. And that's how we get the slope of our perpendicular. That's why it is what it is. There's one proof of it. So for example, with numbers, if you got if we got that, and we want to get the perpendicular, the slope of any line perpendicular to it, you flip it upside down and take the opposite. easy. So for example, like y equal negative 5/3 x plus 10, this doesn't matter as long as it's perpendicular. We just need the direction right. Like if we have a line here, then we can get anything perpendicular to it. There's a lot of things. As long as the direction is right, that's what matters. And so we could also have something like that or whatever. Okay, so get the slope, flip it upside down, take the opposite, and you get your perpendicular, and we went over y. Peace. Hope that helps.